Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week. And the topic is what makes the wind, or perhaps I should have said what makes the wind blow, and what determines how fast it blows. So we're going to be examining the forces that go into making the wind today. So this is the equation for what we call the pressure gradient force. Now, don't freak out here. Yes, this is a form of calculus here, but it's not as difficult to understand as you may think. So the P up here, and let me highlight this for you, up in here, I'm going to pick red. Right in here, the P simply represents pressure, and the Z represents distance, okay? So it's how quickly the pressure changes over a given distance that determines how strong the wind will blow. And so if the pressure changes a lot over a given distance, the wind will blow stronger. If it doesn't change as much over a given distance, the wind will be weaker in speed. So the change in pressure over a given distance is the large part of what makes the wind blow. Then there's one other consideration. The rho that you see in here, this represents density. The pressure gradient force is inversely proportional to the density of the air, which means that the pressure gradient force strengthens as you go up in the atmosphere. As the density goes down, the pressure gradient force actually increases as you go up in the atmosphere, which is an interesting point. And the pressure gradient force is always directed from high pressure toward low pressure, okay? Now, there's something else that needs to be considered here, and that is the Coriolis force, which is a force, sort of an imaginary force, but it has a real effect, and it's caused by the Earth's rotation, okay? So the Greek letter omega that you see here, okay, omega is the rotational velocity of the Earth, and it's usually expressed as radians per second. Now, what is a radian? Well, pi is 3.14, and there are 2 pi radians in a complete circle. So it would be approximately 6.28 radians to go all the way around, okay? So it's how many radians per second that the Earth is spinning. Then, phi, which is this over here, is the latitude. Well, the latitude is 0 at the equator, and it's 90 at the North Pole. So the Coriolis force is 0 at the equator because the sine of 0 is 0, and it increases as you go north or south from the equator. Okay, so the sine of 90 at the North Pole is actually 1. So the Coriolis force at the North Pole would actually be just twice the rotational velocity of the Earth times 1. And this force deflects the wind 90 degrees to the right in the northern hemisphere and 90 degrees to the left in the southern hemisphere. So as a result of that, there are actually prevailing westerlies in both hemispheres. Both the north and the south hemisphere have prevailing westerlies because of this force. Okay, so the geostrophic wind is defined as a balance of 2 forces, the pressure gradient force and the Coriolis force. So let's start off with our trusty little area of low pressure here, and we're going to surround it by areas of high pressure, north, west, south, and east, okay? And remember we said that the pressure gradient force is always directed from high to low pressure. So initially, the air begins to collapse in toward the low. But now we have to take the Coriolis force into effect, which is going to deflect the wind 90 degrees to the right. So as we do that, all those arrows turn 90 degrees to the right, and now you can see easily why the air blows in a counterclockwise manner around low pressure areas and clockwise around high pressure areas. And once this balance is established, then what we have is a balance between the Coriolis force acting to the right and the pressure gradient force acting to the left. And so you get a southerly wind on the east side of the low, a easterly wind on the north side, northerly wind on the west side, and westerly wind on the south side. But, as you might expect, it gets more complicated than this. When the flow is curved, and most of the times it is, at least to some degree, there are other considerations that need to be addressed. And we're going to look at those in the next bonus weather video, which will be coming up on Wednesday or tomorrow. So that is bonus weather video number 1 for this week. Hope that made some sense. Again, the next one will be coming up tomorrow on Wednesday, and the next daily weather update coming up later this afternoon. All right, folks, you all have a good one, and we'll talk to you soon. See you later.